The question of how fast one can lose muscle when ceasing to lift weights is a topic that concerns many fitness enthusiasts and athletes alike. It touches on the interplay of physiology, lifestyle, and individual variability. To truly understand the dynamics of muscle loss or atrophy after stopping resistance training, one must consider several interconnected factors. These include the biological processes that govern muscle maintenance, the role of nutrition, and the effects of lifestyle changes. Moreover, psychological aspects and individual differences play a significant role in determining how quickly and severely muscle loss occurs. Muscle atrophy, or the reduction in muscle mass and strength, is a natural process that occurs when the muscles are no longer subjected to the stress and stimuli they require for maintenance and growth. The principle of use it or lose it is particularly relevant here. When you engage in regular resistance training, your muscles adapt to the increased workload by growing in size and strength. This process, known as hypertrophy, is driven by the balance between muscle protein synthesis and muscle protein breakdown. When you stop lifting, this balance shifts, often leading to a reduction in muscle protein synthesis and an increase in protein breakdown. However, the rate at which this occurs can vary widely among individuals. In the initial weeks after ceasing resistance training, the body may retain a significant portion of muscle mass and strength, particularly if the individual was highly trained. This is because muscle memory, a phenomenon supported by neural adaptations and cellular changes, allows the body to maintain its muscular state for a short period. Neural adaptations, including the efficiency of motor unit recruitment, do not immediately disappear when training stops. Similarly, changes at the cellular level, such as the increase in nuclei within muscle fibers that occurs with training, can persist for weeks or even months, serving as a foundation for rapid muscle regrowth when training resumes. These adaptations act as a buffer, slowing the initial rate of muscle loss. However, as time progresses, the absence of mechanical tension, a key stimulus for muscle maintenance, begins to take its toll. Within 2 to 3 weeks of inactivity, noticeable reductions in muscle size and strength may begin to occur. This time frame can be shorter or longer depending on factors such as age, training history, and genetic predisposition. For example, older adults may experience muscle loss more quickly than younger individuals due to age-related declines in anabolic hormones and muscle protein synthesis rates. Similarly, someone with a long history of consistent training may retain their muscle mass for a longer period compared to a novice lifter, as their muscles are more accustomed to the demands of training and possess a greater capacity for muscle memory. The role of nutrition cannot be overstated when discussing muscle maintenance or loss. Protein intake is a critical factor in preserving muscle mass, even in the absence of training. Consuming adequate protein helps to mitigate muscle protein breakdown, which naturally increases when training ceases. Additionally, overall caloric intake plays a role. A significant caloric deficit, often associated with reduced physical activity, can exacerbate muscle loss. Conversely, maintaining a balanced diet that includes sufficient protein, healthy fats, and carbohydrates can slow the rate of muscle atrophy, even during periods of inactivity. This highlights the importance of dietary strategies in mitigating the effects of stopping resistance training. Lifestyle factors such as activity levels and stress also influence the rate of muscle loss. While resistance training is a primary driver of muscle growth and maintenance, general physical activity can still provide a stimulus to the muscles. Engaging in activities such as walking, cycling, or yoga can help to maintain a baseline level of muscle activation, reducing the rate of atrophy. On the other hand, a completely sedentary lifestyle can accelerate muscle loss. Stress, both physical and psychological, can further complicate the picture. Chronic stress is associated with elevated levels of cortisol, a hormone that can promote muscle protein breakdown and hinder muscle repair processes. Managing stress through practices such as meditation, adequate sleep, and relaxation techniques can therefore play a role in preserving muscle mass during periods of reduced training. Individual variability is another key factor to consider. Genetics, for instance, can influence both the rate of muscle gain and muscle loss. Some individuals are naturally more predisposed to retaining muscle mass due to genetic factors such as muscle fiber composition, hormonal profiles, and metabolic efficiency. Additionally, hormonal fluctuations, including levels of testosterone and growth hormone, can impact muscle maintenance. People with higher baseline levels of these anabolic hormones may experience slower rates of muscle loss compared to those with lower levels. The psychological aspects of stopping resistance training should not be overlooked. For many, lifting weights is not just a physical activity, but also a source of mental well-being and identity. Ceasing this activity can lead to feelings of anxiety or frustration, which may indirectly affect muscle maintenance. For example, reduced motivation to stay active or adhere to a balanced diet can accelerate muscle loss. Addressing the psychological impact of inactivity through alternative forms of exercise, goal setting, or professional support can help mitigate these effects. It is important to note that muscle loss is not an irreversible process. The concept of muscle memory, supported by both neural and cellular adaptations, means that regaining lost muscle is typically faster and easier than building it from scratch. Even after extended periods of inactivity, returning to resistance training can lead to rapid improvements in muscle size and strength, often surpassing the time it initially took to achieve those gains. This underscores the resilience of the human body and its capacity to adapt to changing demands. In conclusion, the rate at which muscle is lost after stopping resistance training is influenced by a complex interplay of factors, including physiological processes, nutritional habits, lifestyle choices, and individual differences. While the initial rate of muscle loss may be relatively slow due to muscle memory and cellular adaptations, prolonged inactivity and inadequate nutrition can accelerate the process. By understanding these factors and implementing strategies to mitigate muscle atrophy, individuals can navigate periods of reduced training with minimal loss of their hard-earned gains. Ultimately, the human body's remarkable ability to adapt and recover offers hope and reassurance for anyone facing a temporary hiatus from lifting weights.